Okay. Lesson 18, we are going to be solving exponents and logs. A little bit more difficult than we've done so far. We introduced log stuff, and I know they didn't do a ton with log stuff yet. A little bit annoyed by it, but that's okay. I feel like they gave me all these objectives to cover, and then I'm like, they didn't even really cover any of the solving. Like, that's stupid. But they did. You do need to know enough about logs so that if you guys, when you graph logs, could choose to graph in such a way that you're solving something, you need to have that skill. So we mainly have taught you guys around the world and how to convert and how to solve if you had to. So you guys can pretty much plan on this exam 3 having most of the majority of the log questions now, okay? So we're going to kind of roll with that where we ended the unit with logs and kind of get to solving anything, okay? So here's how we solve exponential or log equations technically, okay? Always start by isolating the exponent or log term. Okay, so the exponent or log term, you want to get it isolated. And remember how I've talked about whatever is in the log or the exponent is stuck. Okay, so once you're stuck or you get stuck and the x or the variable you're solving for is stuck up in the exponent or it's stuck in the log. Does that make sense by get stuck now? So once you finally have it all isolated, that is when you guys use your changing forms skill, the around the world thing, where your A is the base, or we called B, when I first introduced it. So A would be raised to Y, and then you would set that equal to the X. So now X is considered unstuck, or vice versa. Right here, Y is stuck. So when you guys convert it back and you put your base where it goes and whatever, you now notice how Y is unstuck from the exponent, okay? So we've already learned this. So it's just our around the world. From there, it should be in a form that you guys are able to solve it the rest of the way. Don't forget to check for extraneous solutions, especially on logs. So remembering that logs, we are not allowed to have negatives inside when you're done. You're not allowed to have 0 inside. So since the inside of your log has to stay above 0, when you check for extraneous solutions, if it ever works out that it's not, then you guys have to say extraneous and it's not a typical solution, okay? And that's the process, okay? So we're going to go ahead and start solving. And I haven't made you guys solve ones like this, even though you feel like you have. You really haven't, because we've only given you easy ones to manipulate. And the reason why we taught these to you is so you guys could graph if you had to. But we taught you guys, hey, if the bases match, you can technically just take them and solve. We've only learned that way to solve logs. Well, guess what? Can 5 and 10 be reduced to match bases at all? They can't. So now we have to have the skill set to be able to solve it. Now, we technically did start solving logs a little bit, or exponents a little bit, on your interest day. The day we learned about financial stuff and interest, we did technically start solving exponents. So you have a little bit of skill set. So let's just kind of realize, I want to make that connection that you've already learned it. Let's just kind of start doing tougher ones and different looking ones, because we all know they kind of assess in different ways. So I try to put out as many different looking ones as I can. And now I'm adding to my notes an ln of an x squared plus 3x whatever, because they just, again, they always kind of throw something out there that's going to make you think, in a different way. And they do that to us. I don't know why they do that to us as the teachers, and I get so frustrated. But it is what it is. So, okay, let's do it. How did you guys start this one? I saw some people writing it. It's stuck. It's already isolated, right?
So let's already put it in log.
It's already isolated, so let's already put it into a log now.
Log 5 base.
My base is a 5. Good. 10.
X minus 2.
Good. And then just double check. 5 was raised to x minus 2, and that's equal to 10.
Yep.
And now it's unstuck, and then how does something like this go into my calculator?
Log 10 divided by log 5.
Very good.
Plus 2.
Log of 10 over log of 5. I feel like I see people who think because when we expand, you don't have 2 logs division. They forget that with the change of base formula, there are 2 logs. Did you guys notice that? How many of you were a little tripped up on the true or false question? You're like, wait, which one is this? Is there 2 logs, or is this an expanding? Did anybody remember get tripped up at all? Maybe not. Okay. Maybe you didn't get tripped up. I did when I was taking it. I had to like think twice. So, because I took the test myself. That goes into my calculator and leave it. And then what would you do? Add 2. And then you have it. Now, this is one, I mean, you still want to check for extraneous. I don't want you in a habit of not checking for extraneous. But are there any domain restrictions with exponents? My domain is all reals. So when I go to check it, it would have to be me doing it wrong if I probably got the answer, because there's no really domain restrictions. So the chances of extraneous are a little slimmer on exponents. Does that make sense to everybody? All right, what did you guys get? I don't have my calculator handy, so.
3.43.
Okay, did most of us do that then? 3.43. Okay. All right, let's do a couple where we have to isolate. I'll do this one that's similar to this one, but then we have these other ones where there's multiple x's. There's actually multiple exponents, which gets tricky. And then we have an e. There's just a lot going on. So I want to do quite a few, so we have to practice. What would you guys do first on B? You would, yep. So you get to minus, and then we get stuck here, right?
Yep.
Convert it to a log, and someone tell me what your setup would be. Good. Log base 4 of 8 is equal to x. So check it. 4 to the x was 8. You guys should have this down pat. And I do like the order they taught stuff in, because I feel like we have this down pat. So now that we get to really tricky stuff, we're better prepared, right? Does anybody mind telling me what you got when you put that into your calculator? 1.5. Say that one more time. 1.5. Okay, perfect. And then again, let's get in a habit. If this was the test and I had the time, I would always check all my solving answers. I would always take them back, and all those high stake problems that are 10 points each, I would for sure check them. Okay. Due to time, I don't really like to waste time on that skill since we kind of have it already. Sorry, the formatting gave me issues again. That's supposed to be down there, so you'll have to kind of adjust that. Okay. This is different. This looks a little scarier. And I'm curious the different approaches. So I think it's super important to write down and start somewhere. Start what you know. I had an interesting conversation with my 5th period. I was trying to make them derive something like a formula, because I was like, if I just give you formulas, you sit there and don't know why they work the way that they do, and then you wouldn't be able to come up with it if you can't think of the formula. And so they sat there for a while and nobody was trying. And then I just said, okay, fine, it's extra credit on your assignment if you try it. So then everybody started trying. And then what was cool is they all realized they now have that formula down pat because they derived it themselves, okay? And so I need you guys to realize the power in starting on your own, even if it's wrong. And you try something else and it's wrong, and you try something else and it's wrong. And so I likened it to this, and this is how this one, I want us to see the different approaches we can do. I'm going to pause the video and I'm going to make you try and then see if you get stuck and see if you get to something, okay? And the reason I really want all of you to put an effort into it is you don't realize how you benefit yourself. And I've talked to my 10, at the first of the year I do a better job of setting up the way, and my goal as your teacher is to teach you to have good problem solving skills, to leave here with the skill set to be successful. And hopefully a lot of you guys are going in the STEM direction. And you guys are like the few that are gonna, set us apart and keep us educated as a society, right? The STEM direction kids. And so I want you guys leaving with a skill set. And with you guys coming in a mid-year, I didn't circle back to something I talk about on the day we go through syllabus and all that kind of stuff in August usually. And it's how your brains work. And I want you guys to imagine yourself in the middle of a field, like let's say that you have weeds and stuff way above you, and nobody can see you, and how they would find you if you just like stood in one place and just waited, right? Obviously we're not done and we probably will find a way out. But if you start to try to find a way out and you start a pathway and then you realize maybe that's not the right pathway, you go back on the same pathway, right? You start another one, And I want you guys to visualize all these pathways in the time that you wait for somebody to find you. You start all these pathways through these weeds. Do you think you're more likely to be found now if somebody started and then could connect to one of the pathways and then came back to your overall? You would. And that's how your brain works. If you guys start multiple pathways and then finally that moment of aha, you have the aha moment where something else was taught possibly and you're like, that's why it works. That's how your brain works. And you guys are seriously setting yourself back by not starting those pathways, okay? So I'm going to ask a favor when I'm like, try this. When I do that, it's actually just for your benefit of your skill set. And like, you will become an asset to somebody someday when they know that you're an amazing problem solver and you're an amazing starter. You can start, and then you find in your future career, your future companies you're going to own, you find that your strengths can be someone else's weaknesses. And if you start something, somebody else can also finish things together. And you guys are good. You can really form something strong. But I do not want to partner with anybody or employ anybody. Nobody's an asset if they just sit there and wait to be told what to do. So you want to become an asset to anybody that you are around, right? So as you guys move forward, let's do that. Let's like start things on your own. If I'm sitting there like working on something, start it. And all those things benefit you as a learner and as a worker and as being employed someday. So that's my little spiel. I really feel like I missed that because it's just so busy switching of the semester to just like help you guys become those type of learners, okay, and how your brain works. And mindset is everything. So if I have completely changed the way I coach, knowing something about, like changing my mindset on something. I have completely changed the way, I've tried to change the way I teach because of like, knowing even about like your chemical responses. Cortisol people can't learn. If we can produce like dopamine and then like we produce serotonin, like relationships, and oxytocin is where serotonin is where memories are formed. So I'm like, gosh, it's all about how kids feel when they're around you too. And if they have like this like high level of cortisol because like they're really stressed out, or is this teacher gonna be like super sarcastic or whatever, just things like that. That matters for people's learning. And I've treated my players that way, all my teams. I have been like, you know what, they need this, like we need to lower their cortisol, and this is how learning takes place. So when you guys understand how learning takes place, you guys change the way you do things. If you realize something is high in your cortisol, you gotta change it. Something as simple as going on a walk when you're in the middle of studying for a big exam can lower your cortisol levels, and now learning can take place. And if you guys understand how your brain pathways work, it'll change the way that you guys attempt things instead of always like stopping. I'm probably preaching to the choir because you guys are here because you probably are good problem solvers. But if you notice you're somebody who just kind of like stops yourself, try to change that because it's huge. It's going to be huge for the type of person and type of learner you are. With that being said, these ones especially look kind of daunting. So I want to take a moment and make you try it yourself. And I want you to think about all the properties you learned, even those expanding properties with exponents expanding. I want you guys to go through all the things that we kind of learned. Because my hint to you is sometimes you use logs before you think you would because you want to use its property, okay? So can you talk to your clusters and like, let's make a game plan on how you guys would approach this. Okay, I'm going to pause the video and I want you guys to talk to your clusters. I would love for you guys to share your different approaches. Even if you're stuck now, let's still share, okay? Give me some different approaches. Anybody? Pretend this is an exam and they just threw a little bit of a curveball. You have to write down what you know and try to figure out what skill set do I have, because I technically know how to do this or they wouldn't have asked it, right?
Okay, I changed it to log base to. I changed it to log base to 6 to the x minus 3 equals x.
Okay, hold on. I want some space because I'm actually going to have probably multiple approaches. Okay, let's do your approach here. You said log base 2.
Yep.
Okay.
6 to the x minus 3 equals x, and then I switched the x minus 3 and I expanded it so it's multiplied by x.
Nice. What do you mean switch?
So it's like when you expand.
Good. When you move the exponent down, it's allowed here. Okay, good. She's allowed to bring this x minus 3 down, and this is a number, correct? This log base 2 of 6 is a number.
Yeah.
Okay, did you get stuck, or did you move forward from there?
I then divided the x minus 3 over to the x, but that's all I really did.
Okay. We do have to somehow not have x's in the denominator, so I'm going to not do the division, but that's where we got stuck. Good job. That is a good approach. I do think that is a little more It depends on how you look at it. It could be a more confusing approach, but it is the approach you probably would do because you want to convert bases, right? So we'll continue this, but did anybody start differently? I'll show you a different approach after I work through hers then. Does that work? Okay. We can continue with this. Now, to divide this over does not help us because now x's are not in the denominator, and we normally like to create denominators. So we're going to go away from that, but you don't create denominators when you purposely have cleared them or don't have them, okay? So we now need to somehow get to where I can simplify and add and subtract my x's to the same side. Well, I can't do that until I've taken care of that number being distributed, as ugly as it is. It's ugly, okay? So this is technically a log base 2 of 6 and then an x, right? That's a number. Minus a 3 log base 2 of 6. That's a number as well. And now I can get my x's to the same side. Do you guys want to move this over, or do you want to add that so I don't have a minus? What do you guys want to do? I don't really care. It doesn't matter. I'm going to choose to add it then and bring my x over. Is that okay with y'all if I do that? So, I don't know why, for some reason. I don't love my numbers being negative. There's no like right or wrong way, technically. There. I'm going to minus x. Okay. So, technically, we are right here. I have a number with my x, and I have also another minus x, and then over here is just a number. 3 log base 2 of 6. I know this looks daunting. Hang on. Now, normally, if this was like a 3 minus 4, we would subtract and combine those x's. So, that's a 1, technically. And you can, so how would that look if I was like combining those, like log base 2 of 6 minus a 1x? You get to put them into just like parentheses, right? We can get that decimal in our calculator, but we want exact answers too. So it's essentially going to look like this. If I factor out an x, I get to combine the number parts. It's like me taking 3 minus 4 if that was a 3 minus 4, right? This was a 3x and that was a 4x. I would literally just combine them. That's what we just did. So now we've combined our x's. This is a strategy I need you guys to know. If you ever need x's to be together, but you have an ugly mess going on, still get their terms on the same side so you can factor out that term. Does that make sense? So make note of that strategy or something. That's a strategy you need to have. I think we did it on rational functions, didn't we? When we got the x's and we needed to factor out a y or something. Remember when we did finding the inverse? Remember finding the inverses of a rational on exam 1? And how there was, if there's a binomial, we'll go through it, but that's a strategy you need to be able to get x's on the same side. Okay, this is a number now, so what can I do with it to get that isolated? This is technically a 3 log base 2 of 6. I can do what with this? Divide it. Yep. I'm going to use a different color. So I can divide that ugly mess over here. Okay? So I would call this my exact answer. If they ever ask for exact and decimal answer, this would be considered your exact answer. And by the way, if we had minus to a different side, you would just have minuses in different places, okay? But this is your exact answer. And then we would have to be capable of also putting it into our calculator as the rounded answer. So they might even prefer that you like let us know that you're, oh, I'm a liar. How does that go into your calculator? A log of what over log of what? 3 times log of, oh my gosh, I can't talk. Log of 6 over log of what? 2. So 3 times log of 6 over log of 2 needs to go into your calculator, and then I press equals. And then that's going to be divided by, and I would use a parenthesis because you have a minus going on here. And then you guys would type in a log of 6 over log of 2 here. And then a minus 1. But that all has to be considered in the denominator. And then you have to press equal. What do you guys get? 1.893. 1.893. Darn it, how do we get? 3.8 something. So let's see if I screwed up somewhere. We converted it to a log base 2 of 6. I went with this approach because I used LNs. And so let me see if I screwed up on this approach really fast. I moved that. I got x log base 2 of 6. 3 log base 2 of 6. X. I've got my x's together. Did you get 4.1? Who got 4.something?
I did.
Oh, good. Okay. That's closer to the answer. Okay. Okay, good. So this is correct. Good. 4 point, you said 8?
Yeah, it's 4.892.
892. Awesome. This is what we should have got if you guys are doing that in a calculator. Okay? So yes, if you guys happen to be asked an exponent that has 2 x's, it is ugly. I don't love having this change of base formula, so can I show you guys another trick? Awesome. If you left any space, you could write this down. I actually am probably going to erase this and use the ln way since I'm out of space. And I'll wait so people aren't copying. Is there anybody who... Raise your hand if you're still copying this one down. Okay, I'll pause. Feel free to start some of these others, everybody, while you're waiting. Feel free to give us a go on any of those. All right, I'm going to erase it. Is anybody still copying now? I'm going to erase it. I want to show you a little bit of a different approach. It would have a little bit less change of base formula. And I love this method because, did that get pretty ugly for you guys to be able to have a log base 2 of 6? So, but is it right? Yes. Did we were able to come up with the right answer? Yes. Like it's not like it's the wrong, it just is ugly. And you will be fine on the test if that way makes more sense to you. Stick to it. Don't let me change things. Here's how I handle this. Did you guys know that you can log it with just a base 10 or an ln as well? So I can use a log or an ln. I'm going to use an ln just for a different view or different look. So if I choose to ln both sides, what I do to one side, I can do to the other. This is kind of more like the sciencey way. Science classes use LNs to solve exponents a lot. Or I could just log with a base 10 and not even convert it to either of these base 10s, which I could have, Burke, you were the one that did this one, right? She chose a base 2. Could have we also done this doing a base 6 and did it that way? Yeah. So we could have freed that one, or we could have freed that one. It actually doesn't matter. Okay? So we could have done it either way, and we would have had the same kind of direction. And it's correct. It's actually probably the way you should do it. It's probably the way most teachers probably teach it. Okay? I like this way. I like just bringing logs into the picture so that I know that I can move exponents down. And Berkeley used this skill as well. We knew because we have logs, we can bring exponents down. Okay? So I currently have x minus 3 ln of 6. And then I currently have an x ln of 2. So what's nice is I don't have like the bases to be doing change of base. And this looks more like a number. It's less messy. Okay? And like I said, we could be using a log base 10 right now too. I could have a log as well. Now, I still need to clean up the number thing just like we did with the other way. I still have an x ln of 6 and then a minus of 3 ln of 6. And I obviously still have this over here. What would you do now? We're still doing the same steps. It's just a little less messy. Not quite. We need to get our x's what? We have to get our x's to the same side. So what I'm going to do now is I am going to move this away because that's a number, and I'm going to move this. We want to minus this over, and we want to minus or add that over. Does that make sense? So when we rearrange it, I get my x's to one side, and I minus my x ln of 2, but I moved my 3 ln of 6 to the right side. Do you guys see how I still am intentionally getting my x's together? And now I can factor out my common x, and I have a number. Doesn't this look pretty similar to the other one we had? Didn't we have a log base, whatever? It looks the same, right? It was still a log of 6
Wait,
minus
what'd you
7.
do with the X on the right side? How'd you get it over?
We minused it. Right here. I minused it over. So let's minus this x ln of 2 to both sides. Right, and it's gone. And then I'm adding this 3 ln of 6 over here. Does that make sense? So I essentially swapped them just because this one has an x and that one doesn't. So it's like I got numbers on one side and x's on the other side. Like terms. I'm combining like terms now. So these two are like terms, and now I have their number that's in front of the x, or by the x. And now I do what to both sides? Get rid of the x, right? Or get rid of what's by the x. And how do I do that? Divide that ugly mess over. And that's it. We don't have to do any more change of base formula. This button is actually in your calculator. So here's the exact answer without a rounded decimal. And it's a 3 ln of 6 over, what was that? Ln of 6 minus an ln of 2. And isn't it pretty similar to the other answer? We just had change of bases and stuff like that. But we didn't have to do a change of base formula, and we're actually going to get the same decimal. Will you guys check your decimal answer? And you guys could be using logs here, but you could also be using LNs here. So I could have, can I task somebody with using a log? That's a base 10. Someone use a log, and someone use an LN, and we're going to get the same exact answer. Let's try it. Don't forget to close parentheses, by the way. I usually like to press equal. Oh, this has to have parentheses so they're both in the denominator. You do need to remember when you're dividing that you're dividing that whole thing. That is a calculator mistake that many kids make, is not realizing that's in the denominator. So if you guys are doing it properly, you should still be getting 4.892.
How did we all get it wrong?
Sorry?
We all got it wrong.
When typing it in?
Yeah.
Did you guys close this parenthesis or press equals?
Yeah.
And then did you guys add a parenthesis to this minus? Did you say divide? And then did you do a parenthesis? So you guys have to have parentheses when it's like a binomial in the denominator. Your calculator won't know that it's dividing by the subtraction of those two, the difference of those two, if you don't put a parenthesis around it. Okay? Whew! That is, we're going to do a few more, but that is the toughest thing you're going to see, is how do you handle two different bases with x's in both exponents. That's the toughest. Cool? All right. Now, I know I spent a lot of time on it, but I think it was necessary. Let's just fly through a couple examples, and we should have the skill set to do almost anything. So whatever we have time to get through is great. We should have the skill set to handle almost anything you see in your homework. But some of these are tricky. Are we okay if I skip that one because this one's going to be an E, and we're going to isolate it to look like that? So I'm going to skip it. Those of you who did it already and you want the answer, 3.2, 3.22, for those of you who have it. Okay, so what would I do here?
Subtract 5.
Let's get rid of 5
Divide by 3.
and divide by 3. Ooh, lines. Divide by 3, and then we convert it to an ln. You could also view it as lning both sides, however you guys want to look at it. If I ln both sides, it clears my e. If I convert it to an ln, I still end up with an ln of 3 and then an x minus 1. So whether you viewed it as balancing an equation and lning both sides or converting it, we should end up here. Okay? Either view of how you solve that. And then this is a number in my calculator, so get it in your calculator and finish it off by adding a 1 to it. So exact answer is ln of 3 plus 1, and the 3 is the only thing inside your parentheses. So don't forget to close your parenthesis on the 3 because the plus 1 is not in the log. It's separate. And so what was your guys' decimal answer when you guys tried this one?
2.0861289.
So maybe 2.09-ish? Okay, good. So you're 9.9. I'm okay. Yep, that's great. All right. I feel like so this one is not going to have an X on both sides. So it's going to be pretty straightforward. These two get a little bit more tedious. I don't know if they would ask some. This is harder than I think they would ask, but they always surprise me. So I like to still do them, just in case. However, let's at least start this one. We would what? Add 18, then what? Can those times? No, please don't do it. They are not the same base, so you can't, add exponents. And the 3 is not connected to the 3x minus 4, so don't make it connected because it's not connected. So don't do it. So now you guys said divide 18 by 3. So we're at a 2 to the 3x minus 4, and then what is that, a 6? This is just like an A now. So you guys, just due to time, we would finish this process and it's like A because I don't have 2 exponents. So then I would probably convert this one to a log base 2 of what? 6, which goes into my calculator, and then 3x minus 4, and then we would solve, right? Okay, so due to time, I think we can do that one, and if you guys want to check your work, it's 2.19-ish, so I think that's pretty close to the decimal you would get. Okay, so if you don't mind, I want to jump to these ones that are a little bit like think outside the box. We got to get to logs, so I got to hustle just a little, okay? All right, does anybody have any methods of how we would, these two are very similar, so I at least want to set them up and show the similarities and differences, but how do I do this? Like, it does not help me to divide 3s and stuff over, but what should be something you notice when bases are the same? Yeah.
You can add the exponent.
You can. So that's a strategy. When my bases of an exponent are the same, I can technically add that exponent. Does that make sense to everybody?
Oh.
Now, these bases aren't the same, so we're back to doing what? Our ugly one like before. This is just like that. I actually said that one C would be our worst. I'm kind of a liar. This was a monomial term, the x was, where this is 2 binomials. So there's actually distribution to be done on both sides. So we will do G or H again, so you have another tricky one in your notes, okay? But let's hurry and condense this one really fast. So this would be condensed the same as, and you would add x squared minus 4. And then, I'm a liar actually, I want to do this one. But how can I make this one? So right now it's a 9 to the 4 minus 2x. Does anybody notice something so we don't go through the awful process of converting this to a log? Yes, 9 can be a 3. Please, if they can be the same base, do it. If your bases can be rewritten the same, please do it. Always look there first. Can 3 and 4 be written the same? No, so that one's an awful one. Can 3 and 9? Yes, easy one, right? It ends up being quadratic, so we'll just maybe just continue. So what does the 9 turn into? 3 squared. Perfect. So if this is a 3 squared, what can I technically do with that binomial there? I can technically distribute, right? So this is going to be a 3x squared minus 4 equal to a 3 distribute. Do you guys get 8 minus 4x? And then we can just solve it. This ends up being what type of function? Quadratic. Oops. Quadratics have to be compared to what every time? 0. Try to keep your x squareds. What do we do with our x squareds? Try to keep our x squareds what? Positive. They are way easier to factor, and I noticed a couple of you didn't on the test. Try your best to keep the x squareds positive when you guys can. Did you guys get a x squared plus 4x minus 12?
Yep.
Okay, I was kind of struggling through it as I was talking. I was trying to multitask. It wasn't going well. Okay, what does this factor to?
X minus
X
6.
plus 6, I heard. I heard a couple, yeah, there we are. And then my x's can be what and what? Negative 6 and 2. Was this an equation, so I'm allowed to circle my answers? Yes, it's an equation, right? If it's an inequality, it's an interval, so you have to test intervals. If it's an equation, you guys start throwing answers. Now, what do I need to be careful of? This could be an extraneous, right? So we will normally take the time to take these and check.
X has wait, does X have to be greater than 0?
Uh-uh.
No?
No, and be careful, when we get to logs, X doesn't have to be greater than 0. Inside my log has to be greater than 0. So be careful about just like, oh, can't be it, but be careful about those.
Okay.
Now, when you guys go to check this, you just make sure that it works and that they get to be the same answers when you guys go to check them. Okay, these ones both work. When people are like, wait, how do I check? Let's just for practice sake do one of them. When I plug in a -6, that -6 squared will be a 36, right? So -6, and then we have, this is ugly, eek. Let's see, -6 would become a plus what, like 12 there? And then I can combine those by adding, so that's like a 32. And this would become a 9 to the 16, which can be rewritten as a 3 squared. So it works. Does that make sense? So if it works out, you know you have it correct, okay? Now this one is pretty ugly. I actually might start it, and then when we get to the really ugly process, let me see what time it is, and then we might have to circle back, because I got to get to logs for sure. Okay? All right. Let's convert it, or ln, or log. Which one do you guys want? Do you want to convert it to one of the bases, or did you hate that? Would you want to do just a log or an ln?
ln.
Let's log or ln it. I'm going to try a log with base 10 this time, just so we can see it. Kim?
Could you like times the 3 by 4 and the 4 by 3 to get the same base? And just like.
It doesn't work like that. Yeah, good question. These ones worked because they were the same bases. You have the exponent property that when bases match, you're allowed to add exponents. Do you remember back when x's was our base though, and you added exponents? But there is no connection to those because they are not the same bases. So it doesn't work to times the 3 and the 4 or bring them to the same side or anything. You would have to have them separate and then convert them to log.
So both bases would be 12.
No, because even if I times this by a 4, I can't connect them. And even if I times this by a 3, I can't connect them. And I also just ruined my equation because they're not the same. You're not doing the same thing to both sides. Yeah, I would love, yeah, I'm glad that you're thinking outside the box to manipulate. And that's a really awesome skill to have. To be like, can I manipulate this any further? Like, that's a really good skill to have. So just make sure when you guys are doing your manipulation steps that you're not breaking, like, okay, is this still equal? Am I breaking any properties and whatever? And that was a really good thought. Yeah, really good thought. Yep, your only way is to start using logs. Those exponents are stuck, and my only way is to use logs. And it sucks. So, you guys can use a log with a base 10 or an ln. I'm going to use a log with a base 10 just to show you it's the same process of an ln. So by me logging both sides, instead of converting it to a log base 3 or 4, we eliminate the change of base formula a little bit. And I bring this mess out front, and I bring that mess out front as well. Okay? So I technically am right here. X minus 4 with a log of 3, which is a number, or ln of 3. And I also have this 4 minus 2x times by a log of 4. This number gets to be distributed on both sides now, compared to C where it was only one side. So now I have an x log of 3. We better just finish this actually. And a 4 log of 3. And I have a 4 log of 4 and a 2x log of 4. Okay, what has to go to the same side? I want to bring my x's to the same side. I'm choosing the left side. So I'm choosing to bring my x's to the left side. So what would I do with that negative 2x? Let's add it. So I'm going to add it over here. And I have to bring my numbers to the other side. So I'm going to do what with that? Add it. So we have a 4 log of 4 plus 4 log of 3. This is a number, you guys. You can get that number in your calculator, but we're not quite there yet. what would I need to do so that I can get this number combined and have it all like something x? You technically factor out a what? You technically factor out an x, which is the same thing as me adding them, okay? I'm adding log of 3 with this 2 log of 4. That 2 stays with that number. So 2 log of 4 once I pull that x out. And then this number gets to do what to both sides? Divide. And that's the strategy every time. Okay, so you're dividing this log of 3 plus 2 log of 4, all that. Parentheses are critical, so this would be viewed as your exact answer. Oops. This would be viewed as your exact answer, and then does anybody mind trying this in their calculator and seeing if we can all get to the same decimal?
2.567. Nice.
That's an ugly one. Wheel! That's so impressive, you guys. Good job. Very good. Does anybody else want to see why? Make sure you close parentheses on every log and make sure you add a parenthesis to the whole denominator. Organization. These you have to be organized in your calculator. It sucks, but it's just how it is. I want to move on, but I don't want to move it if somebody's still copying. Anybody's still copying? You're okay. Let me do some logs now. Logs are not, they're the easy ones. Is that, believe it or not? These ones were the hard ones because of the 2 different bases on each side. So logs are actually your easy one. That's why I taught this first, because I wanted to take the time. And then Abby, there's a couple of you right here. You guys all done writing, those of you who are copying things down. Okay, let's move on. Okay, log properties. I don't really care for this question because I don't ask these as much, but what's a valid first step? If I were to ask, you know how they have true and false? If I were to say 15 4x is equal to 20, would you say true or false? Good, not allowed. What would be a valid first step? What if I said 3 to the 4x is equal to 4? Is that correct? Yes. Good. These are the easy ones. You convert them to a log, really easy to solve. If I had another x on top, that's when you guys have the ugly mess, okay? All right, let's do these. What do we remember about logs? We do remember one thing, okay? Let's look at this one. What if I have a log equal to another log? What did I learn? If I have log of x equal to another log of y, what can I just claim? X does equal y, right? So this one's easy. If you have logs on both sides, you guys would take this and just simply act like you eat both sides or converted them or whatever, and then you guys would solve. So those are the easy ones that we kind of hope for. We're like, oh, this would be so sweet if they asked us for a log on both sides. But I doubt they would. They are probably going to make you guys be challenged. So I'm going to not really spend a lot of time on ones that have logs on both sides. Oh, actually, this one has some strategy to it. Let's go ahead. What would I have to do first on something like this one? Isolate the log. And there's actually multiple approaches to isolate the log, and I'm going to tell you why we won't do one over the other, okay? So ln of 5x is equal to 12. What would be my next step? Good. Am I also allowed to move the 2 up to the 5x? I wouldn't do that, though. If you guys can avoid creating an x squared, what happens is we create extraneous solutions. So if you guys create an x squared somehow, you just created extraneous. Don't do it unless you absolutely have to. If there happens to be another log over here, then yes, you have to move exponents, which is like this one. This one I'm forced to, which I'll show you. So when you can help it, if you can divide the 2, please do, because we don't want to create extraneous solutions, okay? All right, what would I do next? Convert it to a what? An e. So e would be raised to what? 6, and that's equal to 5x. Yep, and then we get to do what with the 5? Divide it. All right, in your calculator, you guys will type in e to the 6. Make sure you find that decimal. and then divide that by 5. And what do you guys get?
86.
Good. If you got about 80.69,
Yeah.
80.69, you have it correct. Now, over here is different though. This one's a little bit different. Why does it not help me to divide this by a 2? Or whatever.
You're just dividing it.
You're just dividing it and you're not dividing it to a number and you just complicate things. Yeah. But it does help me make this like a -1/2, which when I move, is it still allowed if I'm doing allowed properties? It's allowed. Like if you're doing allowed properties, you're not wrong and you'll probably happen upon the answer. In fact, if anybody wants to roll with that and see if you get the same answer, great. If you guys are doing allowed properties, that's awesome. Okay? It doesn't necessarily help me. So instead, before I can use this property here, what would I have to do with these front numbers? Because this property is not allowed yet. I can move them, can't I? What do I do with that -1? Put it up to the x1. Yep, this moves up, and this moves up. So in this situation, that's a mandatory thing, where we didn't want to here, okay? So what happens when I have a log base 4 of x to the -1, and then a log base 4 of 3 squared? I get to do what with the logs?
Cancel.
Cancel them, because in my process of solving or exponentiating them, I would have ended up just saying x to the -1 is that number, okay? But x is still not solved for, so what should I do? This is technically a 1. It's technically a 1 over x, right? And then I've got to get that x out of the denominator, and that 9 gets to move. So did you guys kind of happen upon this being a 1/9? Now let's check for extraneous. X in this case has to stay above 0. So is 1/9 above 0, and does it work as far as the domain check? Yes. And if you want to actually plug it in and get the numbers, you can also check it further, okay? I always check it to the domain. That's the quick check. Your quick check is checking it to the domain, and then if you want to make sure you didn't screw up somewhere and maybe did it wrong, you can check it like the actual numbers. Cool? Okay. All right, let's go through other properties of logs we may know. Let me see if I like one of these over the other. 1 second. Gosh, they all have something different, but they're good. Let's go ahead and, I like D. Let's do D. I like it. What property will we do here? Can I drop logs or convert as the form it's in? No. What do we have to do on D? It doesn't, I'm going to do it because I want to show you, okay? Let's move a log over. Let's move log of x over. Does this help me or complicate things, making it look like this? Can I in any way drop logs or convert? No. I'm glad you said it. Okay? So I can't do moving logs when there's a number there. If it was 0, yes. But it's a number. Okay? What do I have to do on the left side? Because I need 1 log. Do we have a skill that allows me to have 1 log? What is that skill? Or the property? We can condense. We know how to condense. So is there something this equivalently can look like now? And it's equivalent. What would I do? They get to times. Yep. I get to bring this these guys into 1 log and times the x by an x minus 9. That's a property. So this becomes x squared minus 9x is 1. Does that make sense? Now we're stuck. So I convert. So how does this one convert when I don't have a base written? It's a 10. So I treat this like it's a 10 and I convert. So I get to say 10 to the first power is x squared minus 9x, and now this is quadratic. So we get to compare it to 0. So always compare to 0 so we can factor, right? Now this one factors, and I'm kind of being quick now. What it factored to minus 10 and x minus 10 and x plus 1. So my solutions are x equals 10 and x equals negative 1. Those are my two solutions. But you got to be careful because we got to make sure they work. Now let's compare it to the domains. I'm going to compare it to the domains first because that's the fastest way. X needs to be above 0, but x minus 9 needs to also be above 0. So x needs to be above 9 actually. So above 0 isn't even enough. It actually has to be above 9 to work in both. Does that make sense to everybody? It needs to be above 0, but above 9 is the real domain. Is this, which one of these works for the domain, which one doesn't? Good. And I didn't cross it off because it's negative, you guys. I crossed it off because it doesn't fit the domain. Just because something's negative doesn't mean it's going to be not in the domain. Okay? For instance, if this was x plus 9, does a negative 1 matter in that one? No. Right? So when you guys check it with the domain, and then we would have called this extraneous. Okay? I would love one more for your notes, but you guys have this skill set. I just had technically, I have a warm up at the end of this that I'll probably start class with next time. So it's going to be there. But other than that, you guys pretty much have it. Do any of these look extra daunting that you guys want to do together? This one's actually really easy, so let's not do it. We would condense, and then it's logs on each side. And these are division, right? This one's unique. What do we do here? Let's do it before the bell rings. I can't condense my right side. What would you do? I heard it. Say it louder. Just one more second, guys, just so we don't distract people. I would bring it over, because if I have two separate logs and you have a number that's kind of in your way, it's kind of causing some problems here. By me adding it over here, I now can invoke all of those condensing properties, and so that's we strategically wanted to make it so we could use that property. And now we do what we did here, times them. Okay? So I get to times, when I bring this inside together, I get to times my x plus 3 with my x plus 4. Okay? So when we go to convert that and I get x squared, what is that times 2? Is that a 7x?
Yeah.
Plus 7x. Is that a plus? Oh, I get so many glitches. Sorry, let's convert. What will be raised to what when I convert? 6 to the 1 power, first power, right? So we have 6 to the first power will be equal to the stuff inside. And now this is our solvable. We can solve this, right? So x squared plus 7x. What is that, a minus 6 now? Nope, plus 6. Plus 6 now? Plus 6. And then you guys would factor. Okay. So look at this one. This one has 2 negative answers, and this is why I like this one, because it had two negative answers, and I'm not going to sit there and be like, oh, they're extraneous, because I don't know yet, right? So let's kind of do our check. Let's check it with the domain first. I think that's the easiest check. X plus 3 has to be above 0, and x plus 4 has to be above 0. That means my x has to be above negative 3, but it also has to be above negative 4. Which one kind of encompasses everything? Let's think of our number line. It has to be above negative 3, but also has to be, above negative 4. Which one encompasses both? Okay, so make sure it's above negative 3. Which of these fails? This one's extraneous then. But negative 1 is allowed. So just because x is negative doesn't mean it's extraneous. You check it with what you're plugging into. If I try negative 1 in here, it's fine. Right? I tried in there, it works. Okay,